Students, this is 102nd class. So let us start one more important new chapter, vector algebra. Vector algebra. Having knowledge of vectors is so important, students, because the role of this vector algebra, the role of this vector algebra, you can see in every field. So all live events can be discussed through vector algebra. Very important chapter. So having knowledge of vector algebra is so important for your future, students. Let us start with our basics. You may have learned something about these vectors in your first physics classes, right? So I am going to repeat the same thing. Look at this, students. Here is a line segment. I am taking line segment AB. That is, you take the length of this line segment as A. So what is the length of the line segment? A. So that is AB. What does that AB mean? What is the meaning of this AB? AB means distance between A and B. AB means distance between A and B. We are taking the distance as what? A, small a. This is the length. We call this length as, so that length as magnitude, and it is a scalar quantity. Length is a scalar quantity. We call that length also by magnitude. Magnitude means length. Magnitude means length of the vector. So look at this, students. Totally it is a scalar quantity. If I give particular direction, now it is becoming a vector. Vector means it is the combined form of both magnitude and direction. What is vector? Vector should have both magnitude, both length in addition to that direction. So the combined form of both magnitude and direction is called a vector. So define vector, students. A quantity which has both magnitude and direction is called what? Vector. A quantity which has only magnitude but no direction. So directionless quantities are scalars. With direction, quantities with direction are vectors. Quantities with directions are called vectors. Quantities without directions are called scalars. Scalar can be length, height, weight, whatever it is. Except direction, we call all the quantities as magnitude or scalar quantities. Magnitudes are nothing but what? Scalar quantities. How a vector is represented? Look at this. Representations are so important. You must learn all the representations carefully. So right, keen observation is required. Look at this, friends. A. If I write A means length. So if I write arrowhead, tale. Idu tale mele bardide nodi. Arrowhead. Then this becomes what? Vector. So representation is so important. You should write both magnitude as well as direction. So you write vector. If I write only AB, it is magnitude, right? If you want to write vector, writing arrow mark is so important. Now it is becoming vector. So tell me the magnitude of this vector. What is the magnitude of this vector AB? AB is length. So with direction of vector AB is from A to B. Tell me the direction of vector AB. It is from A to B. A towards B, A towards B. If I write vector CD, tell me length of this vector CD. Length of that vector CD. CD means distance between C and D. In addition to this length, if I give direction, if I write direction, so it is the combination of both magnitude and direction. It is what? Vector. I hope you are getting some idea about vectors. Vector means writing both magnitude as well as direction is so important. So right, if this direction is not written, it takes the meaning of magnitude, scalar. So scalar and vector, they are completely different quantities. First you practice representations. Practice how to write the vector, how to write the scalar, right? What is the magnitude of vector AB? What is the magnitude of vector AB? AB. Direction is from A to B, A towards B. Direction of CD is C to D. So direction of CD is C to D, C towards D. Scalar quantity, magnitude. We can represent. So magnitude of vector AB. If I write this is means magnitude. What is the meaning of this? Mod vector AB means length of the vector AB. How much is the length of the vector AB? A or AB. AB means distance between A and B. Scalar quantity is magnitude. Scalar quantity with direction is vector. I hope you understood. So what is vector? Vector is a quantity which has both magnitude and direction. A quantity which has both magnitude and direction. So a quantity which has both magnitude and direction. A quantity which has both magnitude and direction is called vector. Or one more definition, a directed line segment is called vector. A line segment with direction is called vector. A line segment without direction is scalar. A line segment with direction is called vector. OR displacement. One more definition. Displacement in a particular direction is called a vector. Displacement in a particular direction is called a vector. So you can write any definition. So they won't ask these things for your exam. I hope you understood what that vector is. Vector means it should have both magnitude as well as direction. Now let's go for types. Triangle law. Now let us discuss triangle law. Triangle law of vectors. Triangle law of vectors. Look at the students. So A, B, C. If a monkey travels from A to B, that is direction is from A to B. Again it travels from B to C. Then you tell me resultant displacement traveled by monkey is AC. What is AC? Resultant displacement. Resultant or net displacement. Net means what? Resultant. If a monkey travels from A to B, then it travels from B to C. Then net displacement or resultant displacement traveled by monkey is from A to C. Resultant, right? We write that in AB, vector AB plus vector BC. Vector AB plus vector BC is equal to what? What is the resultant of sum of these two? AC. AB. Monkey is traveling. Monkey's displacement of monkey is from A to B, then from B to C. Then the resultant displacement, net displacement is from A to C. That is a vector AB plus vector BC should be equal to what? Vector AC. Vector AC. AB plus BC should be equal to what? AC. One thing you observe, this law is called as, this is called as a triangle law. Triangle law. Vector AB plus vector BC is equal to vector AC. Look at this, students. The point B. Point B is called a bridge. What is that point B called? A bridge. Bridge means connector. Connector means link. Point B connects both A and C. Right? Point B connects both the paths. Point B is called as a link. Point B is called bridge. Bridge means connector. Bridge means connector. One thing you observe, students, in a triangle, so while writing triangle, you just remove the bridge. You just remove the bridge from the sum. If you remove bridge from the sum, you will get resultant vector. You remove the bridge. You remove the link from sum. You will get triangle. So removing bridge. Remove. So remove bridge from the sum to get resultant vector. To get the resultant vector. This is called triangle. Look at this, students. I write generally vector AD plus vector DC. Tell me resultant. Tell me triangle AD plus DC. Tell me resultant of this sum. Resultant of this AC. Just before I told you, just remove bridge. What is the bridge in this case? D. If you remove bridge from that, you will get resultant vector AC. One more. If I write Mn, vector Mn plus Nk, vector Nk. Tell me resultant of this. Tell me bridge. N. Remove the bridge to make it triangle. Just remove the bridge. Remove the link. So Mn plus Nk should be equal to what? Mk. Vector Mk. Same thing. Look at the students. So write. Triangle or parallelogram. This is vector A. This is I take this as vector B. This is vector A. I take this as vector B. Then the resultant of these two must be along principal diagonal. Tell me resultant. The resultant, if two forces acting at a point along the adjacent sides of a parallelogram, then the resultant force should be along a principal diagonal. Resultant, correct? So what is this diagonal? Diagonal should be resultant of A and B. That is vector A plus vector B. Vector A plus vector B. Because it is a resultant. Sum of these two principal diagonal. Or you do one thing, you apply that law. So vector B, this is vector B. This also what? Vector B. Vector A plus vector B must be equal to what? A plus B. So sum of these two should be equal to this one. Sum of these two sides, magnitude and direction plus magnitude and direction should be equal to what? This magnitude and direction. Right? This is called as what? Triangle. I hope you understood this triangle very well. This is resultant. Vector A, vector B. Resultant is along a principal diagonal. Or this vector you equal vectors. You bring this vector B this side. Now we will get a triangle. So how much is vector A plus vector B? A plus B. Resultant vector. So two vectors along the adjacent. If two vectors are along the adjacent sides, then the resultant must be along a principal diagonal. Keep that in mind. It is required to solve problems. Resultant is always along a principal diagonal. I hope you understood this triangle. So right, practice these laws, students. Now let us go for types of vectors. 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 Types. So one thing I would like to tell you, students, in these types, surely they are going to ask one question for 1 mark. One more question will be set. One more question will be set on these types. So 1 mark. By head for 1 mark. 1 mark. First one. Zero vector. Define zero vector. First one. Define zero vector. Zero vector. Zero vector. You by head all the definitions, students. Define zero vector. From that name itself, zero vector. Vector with zero magnitude. Vector with what? Zero magnitude. So is called zero vector. Vector with zero magnitude. So but direction of zero vector cannot be said. Cannot be defined. So zero. Magnitude is zero. Direction is undefined. Is called zero vector. Or otherwise, look at this how I explain. Look at the students. AB. So you see this vector AB. What is the direction of vector AB? From A to B. What is the direction of vector BA? From B to A. If I write vector BA, tell me its direction from B to A. It is understood. Right? Look at this. This vector AB, it's having magnitude. Tell me magnitude. AB. Direction is from A to B. A to B. What I am going to do is, I keep on reduce this length until I get 0. I reduce this length until I get 0 because I need a 0 vector. I need 0 vector with 0 magnitude. Look at this, friends. AB. I am reducing, I am decreasing it. So length AB. Next reduce, friends. AB. Next AB. Next, to make the length to be 0, I must make both the points to be coincide. That means I should get a point. A is equal to what? B. This point itself is what? A. You press both. You will get what? Point. Point B coincides with point A. Point A coincides with point B. So tell me magnitude of this point? 0. Still if you are not convincing, still reduce the size of this point very small in the sense the size is almost equal to like this 0.00000. Almost equal to what? 0. ನಿಮಗೆ ಇದು 0 ವೆಕ್ಟರ್ ಅಲ್ಲ ಅಂತ ಅನಿಸಿದ್ರೆ ಅದರ ಲೆಂತ್ ಅನ್ನ 0 ಆಗೋವರೆಗೂ ಕಂಪ್ರೆಸ್ ಮಾಡ್ತಾ ಹೋಗಿ. ಯಾವ ಲೆವೆಲ್ಗೆ ಕಂಪ್ರೆಸ್ ಮಾಡಿ ಅಂದ್ರೆ ಈ ಲೆವೆಲ್ಗೆ ಹೋಗಿ. ಇದು ಗೊತ್ತಿದೆ ನಿಮಗೆ 0.0001 ಆ ಸೈಜ್ಗೆ ಹೋಗಿ. ರೈಟ್? ಐ ಹೋಪ್ ಯು ಆರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್. ಸೊ ರೈಟ್, 0 vectors are nothing but what? Points. 0 vectors are nothing but points. Tell me direction of this point. Does it has a direction? No. We cannot say. For this vector, there is a direction from A to B. For this vector, there is a direction from A to B. For a point, no direction. We cannot give particular direction for that point. Points are nothing but what? 0 vectors. Look at this, students. Now I define 0 vector. So 0 vector. Look at this definition. A vector whose initial and terminal points coincide. If both the initial and terminal points coincide, this point is called as initial point. Initial point means starting point. Terminal point means end point. This point is called as end point. Starting point, end point. End point is also called as terminal point. Terminal. Initial point, starting point is also called as initial point. If both initial and terminal points coincide, then that vector is called as zero vector. ಇವೆರಡು ಕೋಇನ್ಸೈಡ್ ಆಗಿಬಿಟ್ರೆ ಎರಡು ಪ್ರೆಸ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ಕೋಇನ್ಸೈಡ್ ಆಗುತ್ತೆ ಪಾಯಿಂಟ್ ಬರುತ್ತೆ ಅದನ್ನ ಜೀರೋ ವೆಕ್ಟರ್ ಅಂತ ಕರಿತೀವಿ ಅದನ್ನೇ ವರ್ಡ್ಸ್ ಅಲ್ಲಿ ನೀಟಾಗಿ ಹೇಳಬೇಕು ಅಷ್ಟೇ ರೈಟ್ ಸೊ ಡಿಫೈನ್ ಜೀರೋ ವೆಕ್ಟರ್ ಎ ವೆಕ್ಟರ್ whose initial whose initial and terminal points coincide. Whose initial and terminal points, not pointed, points. A vector whose initial and terminal points coincide is called zero vector. By head students, a vector whose initial and terminal points coincide is called zero vector. This can be, they can ask this for your oral exam. A vector whose initial and terminal points coincide is called zero vector. Let's go for one more definition. Unit vector. From that name itself, unit means one, unity means one. Unit vector, a vector whose magnitude is unity, or a vector with unit magnitude is called what? Unit vector. Unity means one. Define unit vector. A vector whose magnitude is one is called what? Unit vector. So I define a vector. Definition. Define unit vector. A vector whose magnitude is unity bracket in or one. Unity means one. The vector whose magnitude is unity is called unit vector. So I hope you understood. Define unit vector. A vector whose magnitude is unity is called unit vector. Note. Look at these students. We represent, if A is a vector, so if A is any vector, if A is any vector, then unit vector along the vector A, so is represented by, is given by or represented by A cap. A cap means we represent unit vector by A cap. So if A is any vector, then unit vector along the vector A is represented by A cap and is given by A cap. A cap is equal to vector by its magnitude. By head students, Whenever unit vector is required, you go for finding a vector. You divide vector by its magnitude. So if I divide vector by its magnitude, if I divide vector, any vector by its magnitude, then it becomes a unit vector. Because look at the students, I go for finding magnitude on both sides. I will go for finding magnitude on both sides. That is length of the vector A cap. Mod means length of the vector A cap. A cap means unit vector. I am finding length on both sides is equal to length of the vector A. I am writing mod on both sides. Length of the vector A. Finding length of length 2 times required? No. What is the meaning of mod length of the vector A? Mod vector A. It means length of the vector A. Is it required to write one more mod? No. So single mod means length of the vector. Even if I write double mod, it is also what? Length of the vector. Length of length required? No, not required. Length of the vector A by length of the vector A. Length of the vector A. I used mod on both sides. That means I am finding magnitude on both sides. Magnitude on both sides. Magnitude of unit vector, magnitude of vector A, magnitude of magnitude not required. Magnitude, finding length one time, finding length once is enough. Need not required 2 times, more times, right? These two get cancels. 1. Length of A cap is 1. So therefore A cap must be what? Unit vector. Length of A cap is 1. Similarly, length of B cap. Length of B cap is 1. Length of C cap is 1. It's 1. They are all must be 1 only because they are all unit vectors. So write point number 3. Point number 3. Note number 3. Look at the students. Point number 3. So vector A cap. A cap is equal to vector by its magnitude. Vector by its magnitude. What define unit vector? Unit vector means vector by its magnitude. That implies vector cross multiply. Cross multiply this side. Length of the vector A into A cap. From this I will write one useful definition. Vector, any vector is equal to magnitude into unit vector. Magnitude into unit vector. This definition is so important, students. So define vector. Vector means magnitude and unit vector. Magnitude into unit vector. By this, what is vector? A general vector is always equal to magnitude into unit vector. So okay students, in this class we shall stop. So remaining we shall discuss in the next class.